All right, geometry. It's week 5, and I may or may not be here. But we're going to start some Ed puzzle videos for when I'm not here, okay? And that is because I won't be able to answer your questions in the classroom. So what we're going to do is we're going to, in the textbook, we are going to do the guided problems in this video. So you still have to do that yellow section, get all the vocab. I'll talk about it a little bit too, but this is going to be about helping you with that green section. And then, yeah, then when you get to class, the blue section can be what you work on, post in the organizer, and I can still help you there. All right, so 2.3 is about conditional statements. If-then statements, which I've told you a little bit about. If P, then Q. P is the hypothesis, Q is the conclusion, and the symbol is this little arrow. You can either write it in words, if then, or you can just write the P and then the little arrow Q. It's kind of cool, right? P implies Q. Yeah. All right, so let's do example 1. Identify the hypothesis and conclusion of each conditional statement. If the forest is rain, forecast. Sorry, it's like 10:30 at night. If the forecast is rain, then I will take an umbrella. All right, this one is pretty easy because it's already in if-then form. So we know our hypothesis, P, and we know our conclusion, Q. And there you go. But now the second one, a number is divisible by 10 if its last digit is a 0. So you see the if, they stuck it in the middle. All right, they're trying to trick you. Don't let them trick you. The hypothesis is now last, and the conclusion is first. So we could say it that way. But I usually like to take whatever they give me and write it in if-then form. So if this was me, then what I would do is I would just rewrite it. If its last digit is a 0, then a number is divisible by 10. And then I can do my thing. So if a polygon has 6 sides, then it's a hexagon. Well, that one's easy. It's already in if-then form. Hypothesis. Conclusion. Another performance will be scheduled if the first one is sold out. Pause the video. Try it for yourself. Okay, welcome back. Another performance will be scheduled if the they just put the if there. If the first performance is sold out, then another will be scheduled. All right, and the hypothesis is right here, and the conclusion right there. All right, moving right along. Example 2, write the conditional and if-then form. So we kind of talked about that. So let me just do the guided questions here. 4 quarters can be exchanged for a $1 bill. If you can say it different way. If you have 4 quarters, then you can exchange them for a $1 bill. And people will be happy because there's a coin shortage right now. The sum of the measures of 2 supplementary angles is 180. If 2 angles are supplementary, then their sum is 180. All right. There we go. Hey, a truth table. If the hypothesis and conclusion of a conditional statement can have a truth value of true or false, as can the conditional statement itself. Consider the following conditional. If Tom finishes his homework, then he will clean his room. Tom finishes his homework, then he cleans his room. True. Tom does finish his homework and he does clean his room. The conditional is true. True. If he finishes his homework but he doesn't clean his room, then it's false because the hypothesis was true. Okay, if the hypothesis is true, then Tom is supposed to clean his homework. Clean his room. I gotta go sleep. All right, so Tom does not clean his room after he does not finish his homework, then he has not fulfilled his promise, right? Yeah. Okay, so the conditional only indicates what will happen if Tom does finish his homework. He could clean his room or he could not clean his room if he does not finish his homework. So here's the thing. If the hypothesis is false, but Tom cleans his room, then it's actually, I believe it's true. Yeah, it's true because the conclusion happened. He cleaned his room. It's true. And then if the hypothesis is false and the conclusion is false, then, oh, it's true now. Why is that? The conditional only indicates what will happen if Tom does finish his homework. He could clean his room or he could not clean his room if he does not finish his homework. Okay, so the truth value is true because the hypothesis is false, so it's kind of like out the window. Doesn't matter. If he doesn't, if our hypothesis is false, then there's no saying what's going to happen. So the conditional is just true by default. It can't be disproven because our hypothesis didn't even work. All right, so the cool thing to know about conditionals, even though that's a little confusing, is that they always follow this truth table. So if you have P and Q, and remember it's true, true, false, false, Q is always true, false, then the conditional statement truth values are going to be true, false, true, true. Okay, example 3 and example 4. We just got example 3 and 4. Truth values of conditionals. Determine the truth value of each conditional statement. If true, then explain your reasoning. If false, give a counterexample. Remember those? Okay, so let's do the guided practice here. If angle A is an acute angle, that's our hypothesis, then the measure of angle A is 35. That's the conclusion. Okay. So I can think of a counterexample when the hypothesis, so remember, if we could say the hypothesis is true, but the conclusion is false, then the conditional is false. So is this a true conditional statement? No, it's not, because guess what? The hypothesis could be true. Angle A is an acute, but what if the measure of angle A was 40? Would it still be an acute angle? Yes, true hypothesis. But it would not be 35 because it is 40, which is different than 35. False conclusion. So then the conditional statement is false. Counterexample, a different acute angle, like 40. All right, if the square root of if x, the square root of x equals -1, then -1 squared equals -1. Interesting. If the square root of x equals -1, so x is a number such that its square root is -1, then -1 squared equals -1. Okay, first of all, -1 squared does not equal -1. But can we think of that the square root of x equals -1? That's false. All right, we know that that doesn't exist in the real number system. There's no square root that equals -1 until you get to algebra 2. So in geometry, we could say that's a false hypothesis. So this is false too. But what do we say about that? When it's false, false, the actual conditional is true. That's silly. That's silly. All right, that's a false hypothesis. So even though this is also false, doesn't matter. The conditional statement is true, has a truth value anyway of true. Okay, so the last thing we got to talk about is different forms of conditional statements. So I just need a little marker here. Got it. So I'm gonna put, okay, I'm gonna put P here, Q here, and then I'm gonna put not P here. I'm gonna put not Q there. All right, that's not Q. P then Q. All right, it's backwards to me. So this is the conditional, and then the converse, the P and the Q switch. And then the contrapositive, they are switched and inverted. And the inverse, okay, the inverse. I'm gonna have to do this in class. This is just not coming out well on the Zoom. Okay, so the converse, the P and the Q are switched. The inverse, they are not switched, but they're negated. Contrapositive, they're switched and negated. Okay, so let's okay, so here we have some examples. So let's do the, okay, two angles that have the same measure are congruent. Okay, so let's make, first of all, we gotta make the conditional. If two angles have the same measure, then they are congruent. All right. Space over here. There we go. Okay, so this is the conditional. Now let's write the converse. Converse. So now we just got to take and switch that. So I'm just gonna cut, paste, and then cut the conclusion, paste it. Then straighten up the writing a little bit. If two angles are congruent, then they have the same measure. So I just switch. So we do for the converse. And then the inverse is negate. So we don't switch, but this time we negate. So now I'm going to copy and paste my conditional. If two angles, what is the negation of this hypothesis? Do not have the same measure, then they are not congruent. And the last one is the contrapositive. I mean, my favorite because it sounds so cool. All right. So this is the negation of the converse. If two angles are not congruent, then they do not have the same measure. All right. There you go. One example, the guided practice questions. So hopefully that helps you when you go to the practice and problem solving questions, and you can ask your questions about these in the organizer so you're ready for your quiz. Wow, look at all these. Wow, there are 62 questions. All right, so look at those carefully. Bye, everybody.